So this is the last question on the task 20. It says, suppose you're standing near a street light. The light pole is 30 feet tall and you are 6 feet tall. Okay, so you have a street pole, which is straight up and down, and this is 30 feet. Okay, or a light pole. And you're standing somewhere and you are 6 feet tall. Okay. And the shadow the light casts is 50 feet from the pole. Okay, a shadow is always on the ground. So this shadow is 50 feet. So from here to here. And it says, how far are you from the edge of the shadow? So you're trying to figure out how far you are here till the edge of this shadow. So I'm going to call that X. Make a sketch of the situation and then try to come up with a solution. Okay, so what we do is we have there, our sun is somewhere back here because that's where it's casting the shadow. And we draw it, we connect the top of our light pole to the end of its shadow to create a triangle. And then I also have a triangle for where I am, my height. I'm saying that's 6 feet. So I'm going to have two triangles. For the triangles, I know that I'm going to redraw. So I have this big triangle with my light pole being 30 feet and my shadow being 50 feet. And then I have this little triangle that has me, my height of 6 feet, and the length between where this end of the shadow is and where I am called X. Okay. And so these two triangles are going to be similar because this angle here is the same angle. So that's one angle. And then the light pole and the shadow have to make a 90-degree angle. Like the light pole is always going to make a 90-degree angle with the ground. And you standing up is also going to make a 90-degree angle. So that's 90. So this triangle and this triangle are similar by angle. And because we know that, we can now set up a proportion to solve them. You want to, when you're doing problems like this, where it's a triangle inside a triangle, to really redraw them because you need to compare the whole triangle side lengths to the smaller triangle, not like part of the side length, which sometimes students do by accident. So when you're doing this, we're going to match up. The 30 goes with the 6 because those are the heights. So I would have like 30 over 6. I'm going to create a proportion again to find my missing side. So 30 over 6 has to give me the same scale factor, the same ratio as the lengths of the shadows or how far the person is from the shadow. So that would be 50, which I'm going to put on top because it goes with 30, and X. And now I can cross multiply this. So I get 30x equals 6 times 50. So 30x equals 300. And then to solve this, I divide by 30. And x is equal to 10 feet. So that's kind of an application problem. It's really basic. It's not something like that's really used in real life, but a long time ago, they found distances using this idea with shadows before we had all the technology that we do. Okay, so that's kind of one application of similar triangles.